Hello, and welcome back to the Ninox Learning Series. My name is Andy. I'm a Ninox programmer and trainer. And in this class, we're going to continue our discussion of various looping structures within the Ninox programming language. Now, in previous classes, we've looked at the if-then structure and the case or switch structure. In the next class, we're going to look at the for structure, but in this class, we're going to look at the while-do repetitive looping structure. Now, in the if-then, case or switch, and for next structures, one of the things they all have in common is we know when the repetitive loop or the structure itself is going to end. An if-then will end when the evaluation is complete and the system, Ninox, has done this, or else it has done that. And as we know from our previous class, the case switch structure will complete once the case has been evaluated and it is then resolved or switched to the proper result based on what the case was. We know when those two structures are going to end, and as you'll see in the next class, the for next loop is pretty much the same way. It's going to end when it has executed a defined number of times. The while do is the one repetitive looping structure that allows us to create a process that is run over and over again without having to know how many times it needs to repeat in order for us to achieve success. For example, imagine a loop that is looking for a particular value, and it has to look at thousands and thousands of records to find that value. Now, of course, this is a very simplistic example, and we could use the find mode or the search engine built into Ninox. But again, to speak in terms of the example, imagine you're looking for something. You don't know how many records you're going to have to look at before you find it. But once you do find it, you want to stop. This is a situation where you know what you want, you know where to look, and you know what you're looking for, but you don't know how long you're going to have to look. You don't know how many records you're going to have to look at to find the one you're actually looking for. This is an example, a basic example, but an example nonetheless, of creating a looping structure that does what we need it to do without us having to predefine how many times it repeats itself. Now, this is very valuable because, as we noted in the if-then structure, we want to write compact and efficient code. The reason the case switch structure was so valuable to us is because it was more efficient than nesting a bunch of if-thens, forcing Ninox to test a number of situations, knowing well and good many of those tests would fail. Same thing with the while do. Instead of telling Ninox to search every record, even after it's found the thing it's looking for, we can use the while do to tell Ninox, keep doing this until something is achieved, until the current state changes. And the minute that change takes place, the minute we have achieved our goal, stop repeating yourself. This is tremendously efficient code because it only works as many times as it needs to. It only repeats as many times as it needs to achieve success. And that time could change. We could write a subroutine that could search any specific table for any specific value. In one table, we might have 100,000 records, and success lies in record 96,000. In another table, we might have 500,000 records, and success lies in record 26. A while do loop will only run the minimum number of times to achieve success and will immediately stop as soon as that success is achieved. And it will stop no matter how many times it's run, one time or hundreds of thousands. This is what we call smart looping. Ninox not only knows what to do, it knows when to stop without us giving it a specific, discrete endpoint, without us saying, do this many times, or evaluate all of these if-thens, even if you have to evaluate a number that fail. So let's now go ahead and take a look at the while do structure. It's tremendously powerful and really easy to use. Let's go ahead and take a look. Now, what I've done for this example is created a very simple database consisting only of two tables. One table is called invoices, and it contains exactly that. 300 plus, I guess, what about 390, 400 invoices to a variety of different customers, each invoice having a date, an invoice number, and a variety of amounts. Service fees, product sales, warranty sales, and then an invoice total, the total amount that we billed for this particular document. We are going to demonstrate the while do loop by searching in this table for a specific value. We don't know when we're going to find that value. We don't know how many times the loop will have to repeat, but we do know that as soon as the value is found, whatever the number record we're on, that's when the loop should stop. So here is the data that we're going to search, and here is what our structure looks like. Now, for purposes of this example, we're going to search for a specific invoice number. We're going to click this button, and when that number is found, when that invoice number is found, we want Ninox to tell us which record it was looking at when success was achieved. For now, I'm going to delete these two fields, and let's see how this works. I'm going to go ahead and enter an invoice number, in this case 41670. I do not know which of the 300 to 400 invoices in my invoices table is numbered 41670, but I do know I need to find it, and I know that I want Ninox to stop looking as soon as success is achieved. We click the button, and it turns out that out of the almost 400 invoices, it was invoice record 371 that was numbered invoice number 41670. Let's see how it works. I'm going to go into administrative mode, and for purposes of this demonstration, we've embedded the sample of the while do loop in the button. Now let's look at what we have. Here we have defined a variable called search code to be equal to that which we are looking for. Remember, we had this field set up called search code. The contents of that field is being installed or put into this variable. We then are going to set a switch or a little flipper, and we want Ninox to keep looking until found is yes. As long as we haven't found it, we want to keep looking. While found is equal to no, keep looking. But the minute you find what we're looking for, flip the switch to yes and stop looking. And then we've simply set up a counter here to count the number of times we have to go through the loop. The key element to this, what we've discussed so far, is right here. It's the trigger. We don't know when the trigger is going to be pulled. We don't know when the switch is going to be flipped. But we know that it's going to get flipped at some point, and when it does, that's when the loop should stop. Now, the loop itself, from a syntax perspective, is really quite simple. We start with a keyword, again, and as always, in all lowercase, the word while, W-H-I-L-E. while some condition is true, do the following. And when this condition stops being true, stop doing whatever it is we told you to do. As long as no, we haven't found what we're looking for, do this. But when found is yes, stop immediately. Now, what is it that we're actually asking Ninox to do? Remember that counter we set up? It starts with the value 1. And what we are doing is we are going to select every record in the invoice table, starting with record number 1, which is designated in the ID field. When the ID equals 1, return the invoice number, and return that invoice number into the variable I. And then we check to see if we have achieved success. If I, which is the number of the invoice that we just looked at, equals the search code, equals what we're looking for, then do the following. Go in and select the invoice that is that number, the number that we're looking for, the search code, and tell me the number of the record where you found it, and put that value in the variable F for found. Then go ahead and document in the results field, which I'm calling the record ID number, the following concatenated value: the text, invoice record, space, and then the number of the record, which again we selected here and installed into the variable F. That record is the record of the invoice number equal to the one you were looking for, in this case, the search code. Then flip the switch. Change found, or the variable X found, which currently is no, now make it equal yes, to indicate that we have now achieved success. However, if the value I, which is the invoice number of the invoice record we just looked at, is not the one we're looking for, then simply advance the counter 1 tick. For example, if the counter right now equals 1, we looked at invoice number 1 in the invoices table. If invoice number 1 was not the one we were looking for, now go look at invoice number 2. 1 plus 1 is 2. If invoice 2 is not the record we're looking for, advance the counter another tick. 2 plus 1 is 3. We go look at invoice number 3, and we continue to advance our counter 1 tick at a time, which is forcing Ninox to look at every record in a table 1 record at a time until it finds the record that contains the value in this field, the invoice number field, that is the value we're looking for, the value we typed into our search code. So here we're doing a couple of things, and these are things that we've learned in other classes, but I'm looking at them in a new way. We're applying them in a different way. We've embedded if structures inside of other if structures. We've embedded case structures inside of case structures and if structures inside of case structures. Now we're going to evaluate and embed an if structure inside of a while. What we are doing with these two looping repetitive structures embedded inside of each other, the if inside of the while, is we're saying, while you are not finding what I'm looking for, keep looking. And if you find what I'm looking for, stop. Now, this again is a very basic example, but think of all the different ways you can apply this. Think about when you need to execute a search to find one record that has multiple values or values in multiple fields. Right now, we're simply searching the invoices table to find an invoice number. Well, the truth is we could have done that simply by clicking on the Find button right up here in our sidebar or in the upper panel. However, the Find feature looks for a value in a field. What if we're looking for a record that has a value in this field and a specific value in that field, and a different value in field number 3, and yet another value in field number 4? The find function does not allow us to search for different values across multiple fields within a table. Within a record, and then multiple records within a table. Now you might be thinking to yourself, well, we could use the phrase search table where field 1 equals this, and field 2 equals that, and field 3, and on and on and on. The and clause, which is a conjunction, allowing us to search for a value in this field, and that field, and that field. Now, that would work, but if we do it in an if, it's going to search every single record. And if we do it in a case, there's no way to actually do it in a case, because a case structure requires us to know how many different results can be achieved. The while structure is the one looping repetitive structure where we can tell Ninox what to do and let Ninox decide how many times it needs to repeat the process to achieve the success we're looking for. This can be tremendously powerful. Now, yes, there are a variety of ways to do this, and that's one of the beautiful things about Ninox. Whatever you need to do, there's 1 or 2 and sometimes 4 or 5 different ways to do it. But this is a really simple, easy way to let Ninox know what needs to be done, and then turn the system loose to do it, and let Ninox decide when success has been achieved based on our criteria, stop immediately what it's doing, and return the results of the successful achievement, whatever it was we were trying to do. Again, the syntax: while this situation is true, do the following. And this can be any code you want it to be. At some point in time, when your code has achieved success, you found what you were looking for, you executed the 100,000th calculation, you define success. And as soon as success has been achieved, then have Ninox flip the switch. It could be a 1-0, a yes-no, a true-false. Doesn't matter. You get to define what the switch is. But the switch should be an on-off binomial, a black-white, yes-no, 1-0 type of switch. In this case, I'm using a yes-no switch. As long as found is no, keep looking. Do the following. When you have achieved success, flip the switch to yes, and that will force the loop to stop, and then return or do whatever it is I tell you to do, Mr. Ninox, or Miss Ninox, depending on your perspective. Return or do what I tell you to do as soon as success is achieved. This is a very flexible, very powerful, and really simple looping structure that can be used all different ways as we build more and more complex and more powerful database applications. Let's now see it in action. We've looked at the code. Let's take a quick look at what it can do. I just found invoice 41670. That happened to be record 371. If I want to find invoice number 85301, I know it's somewhere in that table. Don't know which record it is. Ninox will find it for me. happened to be record 226. Now that's another thing that I like about the while do. It not only allows me to control the definition of success, and it not only allows me to tell Ninox what to do and let Ninox figure out for itself when to stop doing it. When I'm doing a find, it returns the entire record that I was looking for. And if the thing I'm looking for is found in multiple places, it returns all of them. I can tell Ninox what to look for, but Ninox is going to bring back everything related to whatever it found. In the while do structure, I not only can define success, and I not only can define what is to be done, what Ninox is to do while the loop is in process, I also can define what happens when success is achieved. When success has not been achieved, repeat the loop. When success has been achieved, do what I tell you to do. And what I told Ninox to do is compose this sentence, the words invoice record, insert the number of the record, add the text is invoice number, and then repeat the number that I was looking for, which is the search code. If I'm looking for invoice 39294, that's record 369. And finally, 85301, record 226. Record 41670, I'm sorry, invoice 41670, 371. You get the idea. Now, using the while do, you now have taken a huge step in building your own custom search engine. What is a search engine? It's a system that allows you to tell the computer what to look for, optionally tell it where to look, tell it how to look by looking at numbers or letters, and then tell it what to do when it is successful in what it found. This is all you need to build your own search engine, which means you now can build your own business intelligence dashboards using this simple while do structure. You can tell Ninox where to look, what to look for, how to look, and what to do when the looking is over and the found or the success has been achieved. One simple structure, the while do structure. You can put it into a button. It can be a trigger either at the global level, the table level, the field level, or the record level. You can use this simple code, and by simple I mean less than 15 lines, 13 lines of code. I'll get rid of the blank at the end. With a dozen lines of code, I've built a search engine. And with a little more code, simple basic code, with a combination of if-thens and cases and using the select statement, which we looked at 2 or 3 classes ago, we now can build our own search engine, which can be as complex as we want it to be and tremendously powerful while we have all of the control. That's the while do looping repetitive structure. Simple to use, powerful as heck, and really, really useful when you know what you need to do, but you're not sure how many times it's going to get done. This is yet another level of intelligence that we can give to Ninox. Ninox knows what to do, it goes out and does it, and it knows what success looks like, and it knows when to stop. That's it for this lesson. In the next class, we're going to look at the 4th and final repetitive looping structure, the 4 next structure. I hope you enjoyed this class. It was a short one. I hope you learned something. I hope you had fun. And I sure hope you'll come back and join me in the next class when we look at the 4 next loop here on the Ninox Learning Channel. Thanks very much. Goodbye.